Okay. If f is the antiderivative of a function, how do you find f? You take the antiderivative. Can you take the antiderivative of this? Some of you are trying to, but you can't. So if you can't take the antiderivative, how do you write the equation? How do you write an antiderivative? What's the notation for antiderivative? You guys will kill me. The integral of sine cubed x from, or dx, sorry, this shouldn't be x, this should be t. What's the lower bound? Right, because the initial condition was 1 comma what? 0, because f of 1 is 0. So the lower bound is 1. Remember the x value of the initial condition is the lower bound. Where's the y value go? It's the plus thing. Plus whatever, right? Because when you plug in 1 to the top, if you plug in 1 to f of x, you're going to get the integral from 1 to 1, which gives you what? 0. So if this was anything other than 0, you'd have to add something to it to make it the value you want. Does that make sense? What's the upper bound? Well, x is for the function. Now I want f of 8. So what changed? I just plug in 8 to the upper bound. So the integral from 1 to 8 of sine cubed t dt. What did you guys get as an answer? 0.632. Are you guys okay with this? Yes. Number 2 is something we talked about yesterday. If you graph this over the interval it's talking about, I think it does something like this. If I remember right. Am I right? So you guys didn't do it. Oh. If you look at the domain from 0 to 3, that's what the graph looks like, right? If I am looking for area, what does that mean I'm trying to find? Total area. So if I just find the integral from 0 to 3, what am I finding? Net area. I don't want that. What's different about net and total? This piece has to what? Has to flip up to make positive, right? So I can break this down into 2 separate integrals. The integral from 0 to 1. Why 1? Because that was the point, the x-intercept, right? The integral from 0 to 1, and I'm just going to name that y dx, because it's y. Then what? Plus the integral from 1 to 3 of y dx. Is that true? No, this is not true. Because this value is a positive value. This value is a negative value. So you could write it as plus the absolute value of that. Or you could write it as the integral from 0 to 1 of y dx minus the integral from 1 to 3 y dx. Probably not the best notation to put a y there, but I just don't want to write the whole function. Are you guys okay with that? Because this integral is going to give you a negative number, so I subtract it, so it turns into adding it, right? Okay. So you could go through all the antiderivative of each, plugging it in and solving it, but what would you be typing into your calculator? The integral from 0 to 3 of what? The absolute value of x cubed minus 3x squared minus x plus 3 dx. Are you guys okay with that? Yeah. Remember, we don't take the absolute value outside the integral because what does that do? It just gives me the positive value of what? The net area. The total area is not going to be just the absolute value of the net area. This is flipped up, so we have a positive value plus a positive value. What did you guys get for this? 5.75. 5.75? Agreed? Yes? Okay.